The quickest way to get started with the Entity Framework from this console mode application would be to right-click References, go to Manage NuGet Packages, and now I want to download a stable release of the Entity Framework. Quite often you have to search for your package here in the search box, but the Entity Framework is popular enough to appear in the opening page of this dialog, so I'm just going to select that and click Install. And while that installs, I'll just say that this is not a course on the Entity Framework. If you want detailed information, see Julie Lerman's course. I also have some videos on the Entity Framework. We'll just be focusing on the bare minimum needed to get this up and running in a console application. And now that it's installed, I can create a new class. Control-Shift-A to add a class to this project. I'll call it dataaccess.cs. And I really just want a file to put in a number of classes. Again, I would usually split those out, but it's easier in a demo to keep things in fewer files so I don't have to switch around as much. I want a place to store employees, so I will call that EmployeeDB. It's going to derive from the Entity Framework's DB context class. That's in the system.data.entity namespace. And once I have a DB context class, I can create DB set properties that will describe the types of objects that I want to store in a database. And I describe those objects using a generic type argument. So I want a DB set of employee. I'll call this property employees. And that's pretty much all the information that I need to give the Entity Framework to be able to store employees in a database. And we're going to use all the defaults. So the Entity Framework gets to pick the server, create the database, create the schema and the tables, and give me everything I need to save employees and query employees. Now, one quick word of warning about this demo is that I plan on storing not just employees, but also managers because they derive from employee. And in a real application, I would want to use some additional configuration to make sure that works correctly all the time. But this is a simple demo. I'm going to be able to get it to work without any additional configuration. That's just a warning if you use inheritance with the Entity Framework, make sure you do some research and set up your mapping correctly. But I'll be doing some relatively simple things that should just work. And the first thing I'll do is start to create some sort of abstraction, like a repository abstraction, that will sit between me and the Entity Framework. Let me call that an iRepository of T, a generic type parameter because I want a repository for employees and a repository for accounts and a repository for customers. We might have all different sorts of repositories. And typically, a repository is going to access some sort of resource. Might be a database, might be a file, but quite often those resources need to be properly cleaned up and disposed of, so I'll have iRepository of T also be something that is disposable. And now what sort of things would I want to do with a repository of employees? Well, I would certainly want to add an employee or any sort of entity. I don't know if this will be an iRepository of employee. That's the only one I plan on using, but I'll try to write this code and use parameter names that don't tie this to a specific type. So I'll just say you want to add something, sure, add something of type T, we'll call it new entity. And at some point I might want to delete an entity. I'll probably want to find an entity by its primary key value. So I'll have a find by ID method that returns a T. I also might want to find everything in the database. So give me back all the entities, but I'll return that as iQueryable of T, so I can continue to use some link operators and expressions, because chances are I will want to filter that list of everything. And one more piece that I'll need is a commit method. So when I'm using the repository to add things and delete things, eventually I'll want to call commit, and that's the point where changes should be reconciled with the database. Things that were added should be inserted, any objects that were queried and changed should be updated, and anything that was marked for deletion should be deleted from the database. And the next question would be, how can I build a class that actually implements this interface and uses the Entity Framework to perform these actions against the database? Well, let's see what I can do. I'll create a class, SQL repository, because it actually talks to SQL Server. It'll be a SQL repository of T and implement iRepository of T. So some of the generic techniques that we saw from earlier in the class. Implement a generic type, a generic class that inherits from a generic interface. and I'll use Visual Studio Control Period to give me a starting point for an implementation. So how would I add something? Well, I'll need an instance of a DB context class to be able to do anything with the database. So let me go ahead and create a constructor for SQL repository. I will ask that you pass in a DB context. Why not an employee DB? Because we're about to see that SQL repository can really work with any type of DB context. It doesn't need the specific derived type. The specific derived type is really here for me to instantiate to let the entity framework know what I want in the database. Right now, just employee objects. But when I'm using this DB context from a class like SQL repository that doesn't know if it's going to be querying employees or some other type of entity, it really doesn't matter if I use employee DB or DB context. We'll see that in just a second. I will create a private field to store this value in. So context equals this incoming context parameter. And there's one more thing I'm going to save in here. I want reference to a DB set of T. I'll call it _set. And this set represents the DB set that I want to interact with. So if I have a SQL repository of employee, I want a DB set of employee because it's ultimately the DB set that lets me do things like add objects, delete objects, and query for objects in the database. And the question is, how do I get that set? Well, it turns out the DB context has a rather nifty method that you can use when you have a generic type parameter. And that is, I can walk up to the context and I can say, please give me the set for this particular type T. And it will go off and look at that DB context and find the DB set for that parameter T. Now you notice that the compiler is not particularly happy about this line of code at the moment. I have the red squiggly line underneath of it. We'll come back and investigate that in just a second. When someone tells me to add a new entity, I want to be able to walk up to this DB set and say, yes, let's add that entity. And now my implementation for add is complete. We'll come back and implement some of these other methods later. For right now, I will just implement commit, which is simple as going up to the context and telling it to save changes. And I'll also implement the dispose method, where we just assume that we have a working context. And we'll forward the dispose call down to that context. And now commit, I did say it should return an int. So I will return the return value of save changes because save changes should tell us essentially the number of records that were affected. And now, before I can get this working, I need to resolve this problem here. It says the type T must be a reference type in order to use it as a parameter T entity of DB set. What is it talking about there? Well, DB set has certain restrictions on the types of objects that you can use, the types that your entities are going to be. And I can actually see that if I go to DB set and I press F12 to go to the definition, Visual Studio can show me that DB set of T entity implements DB query, IDB set, iQueryable, a number of things in here. And here at the very end is a generic constraint that essentially says your T entity has to be a class definition. In other words, it has to be a reference type. It cannot be something that was defined as a struct or an enum. The entity framework won't allow those to be entities. It has to be a reference type. And because DB set has this requirement, the C# compiler is smart enough to come along and say that my type parameter inside of SQL repository has no restrictions. It could be an enum. It could be a struct. It could be a value type. And if someone does create a SQL repository of date time, that's going to be a big problem because the entity framework has said this DB set that I'm trying to use will not work with value types. How do I solve that problem? By using a generic constraint and saying that SQL repository of T implements iRepository of T. And by the way, the generic parameter T has to be a class. So now I'm enforcing the same constraint as the DB set. And now the C# compiler is happy. And this is our first look at generic constraints. But you might not be seeing exactly what problem that solves just yet. We'll get to that, I promise. For now, let's just try to get something working and something saved in the database.